13.3, Solving Absolute Value Equations, Algebra 1. Essential question, how can you solve an absolute value equation? Your first example, the absolute value of x plus 2 equals 4. When solving for an absolute value equation, you are going to come across a disjunction. It's basically an OR statement because we have two different situations for an absolute value. So, we have two situations. One situation is the absolute value of 4 will equal 4. Another situation is that negative 4 inside an absolute value will also equal a positive 4. So this is what we call a disjunction. It's basically two different situations, and either one of them can play out. So let's go ahead and set up our disjunction. Notice how I'm just taking my absolute value expression and I'm writing it in two different places. Except in one scenario I have a positive 4, and that's because the absolute value of a positive 4 is still going to get me my 4. But on my other situation, I want to have my absolute value expression equaling the negative 4. And that is because the absolute value of negative 4 will also get me positive 4. So notice how you have two different situations that will get you the same true statement. Therefore, we have two different solutions. Okay? So let's go ahead and solve for x, and I'll further my point. We'll use a subtraction property. We're working on eliminating our x's. And you notice that we have two different solutions, x equals 2 or x equals negative 6. And that's because, well, if we were to substitute, again, our x equals 2 right here, if we were to substitute it into our original absolute value expression, we're going to get 2 plus 2, which is 4. And I've already set it up here that the absolute value of 4 is, well, 4. So that checks out. And then if you look at our other situation with x being negative 6, we'll go ahead and substitute into our original absolute value expression. Negative 6 plus 2 is negative 4. And I've already said that, well, the absolute value of negative 4 is going to be 4. Oh. So notice how a disjunction is really just two different solutions to the same problem. So your solutions here will be x equals 2 and x equals negative 6. So our answer to the essential question is that we isolate the absolute value expression, then write two related equations with a disjunction. This is also known as an OR statement. Your definition: a disjunction is a mathematical statement created by connecting two other statements with the word OR. Example 1 will be solving absolutes by graphing. So we are going to solve this equation 2 times the absolute value of x minus 5 minus 4 equals 2. In reality, we have two different functions equaling one another. This part of our equation is f of x. The 2, on the other hand, is g of x, and we will get to him. So we're going to go ahead and graph f of x. So if you remember our last section, when you're graphing absolute values, we need to think about our vertex. And remember, our vertex is at negative h, comma k. And basically it just says, whatever your h is, which our h happens to be negative 5, well, who's the opposite of a negative 5? Positive 5. And then our k is negative 4. So our vertex will be at 5, comma, negative 4, right there. So let's look at our a value, our parameter. So it looks like we're going through a vertical stretch, okay? So instead of going up 1 over 1, we're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And to the left for our other ray, up 2 over 1, up 2 over 1, up 2 over 1. And we're just following that pattern. And I'll try to cautiously draw my rays. Now let's deal with g of x. So our g of x will be the red guys. G of x equals 2. And remember, g of x is just function notation. If you were to rewrite him in context to our graph, he'd probably be called y equals 2. So go to where 2 is on your y, and you're going to just draw a straight line cutting across. Okay. Its slope is 0. That's why it's a flat line. Now, if you notice, we have two different intersections between f of x and g of x. And that is when x equals 2 or at x equals 8. And it's a terrible 8. That's slightly better. There. So notice how we can solve absolute values equations by graphing. And again, solutions are basically your intersections, okay? Just like with systems. So solving algebraically for example 1, I'm going to go ahead and ignore whatever my absolute value expression is on the inside. So I'm not worried about the inside. I'm not worried about 3x. But I am worried about getting him all by himself. So I'm going to go ahead and use the subtraction property. And all I have left is the absolute value of 3x equaling positive 6. Now I'll set up my disjunction, which again is going to be an OR statement. So in the left corner, we have 3x equaling negative 6. Or in the blue corner, 3x equaling his positive brother 6. Okay, so basically we're just going to solve. Use division property. X equals negative 2. Or we're going to solve for our other situation. Notice how the process is the same, just different number. And then x equals positive 2. So we found our solutions. If we were to graph it, negative 2 would be plotted here on the number line. And then our positive 2 will be plotted right here on that line. Example 2. Again, I'm not worried about what's inside my absolute value. I just want to get my absolute value alone. So I'm going to go ahead and get rid of that -2 with the addition property. I have 3 times the absolute value of 4x minus 5 equaling 21. I'm not worried about inside my absolute value yet. I'm not worried about my disjunction. I just want to get my absolute value alone, which means I have to divide that multiplying 3. So I'll use the division property. And finally, at last, I get my absolute value all by himself. And now I can solve for his disjunction. 21 divided by 3 is 7. So we have our disjunction going. So we have two situations. We have 4x minus 5 equals 7, or 4x minus 5 equals, who's the opposite of positive 7? Negative 7. So let's go ahead and solve. We'll use the addition property. And if you notice to your right, you would start that way as well on the green side. We get 4x equals 12. Use the division property. And you will get x equals 3. Or, and this is where we get to solve for our green guy. Let me graph x equals 3 real quick. There we go. For our green guy, we will do the same process. Notice how we were going to get a different answer, though. Got -2 this time because -7 plus 5. We'll use the division property. X equals -1/2. I went ahead and reduced. Okay, -2 divided by 4 is -1.5. And that should be graphed right here. Okay, and that's how you graph it. So your solutions, again, was x equals 3 and x equals -1/2. Okay, example 3. This one's kind of nice. We don't have any plus or minuses after the absolutes. We have a multiplying 1/2. So we can use the reciprocal rule. Alright, 2 divided by 1 is the reciprocal of 1/2. Make sure when you distribute to coefficient here and to the right hand side. So 2 times 1/2 is 1. So I just get x plus 2 as inside my algebraic or absolute value expression, equaling 20, because 2 times 10 equals 20. Now we can go ahead and set up our disjunction. We have x plus 2 equals positive 20, or we have x plus 2 equals the opposite of positive 20, which will be -20. Let's go ahead and solve. We'll use the subtraction property, and you'll get x equals 18. Or we will go ahead and solve for the other situation, subtraction property. X equals -22. And let's go ahead and graph them. So here's our solution, or I should say solutions, plural. And when we're graphing, it looks like they're going up by 4s on the marks. Okay, so when you graph, pay attention to the units. x equals 18, that's halfway right here between 16 and 20. And negative 22 is halfway between negative 24 and negative 20. All right, now we are going to have some special solutions here. We're going to have no solutions and one solution. Basically absolutes with less than two solutions. So if I go ahead and solve for our example here for no solutions, I will go ahead and work on getting my absolute value all by himself. I'll use the subtraction property. And notice how I'm basically just solving like my previous examples. 12 minus 2 is just 10. I have a multiplying negative 5 coefficient, so the inverse of multiplying will be division. So I will use the division property. And I will get the absolute value of x plus 1 equals positive 10 divided by negative 5 is negative 2. Uh-oh. Do you guys see the problem with that? Can you have a negative number after you take the absolute value of it? Can you? No. That's impossible. Okay? When you throw your clothes into a washing machine, your dirty clothes into a washing machine, you're going to get clean clothes when you're done. Okay? So, if not, the machine's broken. Okay? So, whenever you have a negative number on the right-hand side of your absolute value expression, your answer is always going to be no solution. So you need to notice whether or not the guy on the right of your expression is negative. If he is, stop what you're doing and write that down. You're good. Okay, one solution example. So let's go ahead and solve for this guy. I'll use the addition property. And I'll go ahead and get 3/5 times 2x minus 4, and that's all absolute value, sorry. And that's all equaling to 0. Okay, we got a 0 on the right hand. I will go ahead and do the reciprocal of 3/5. I'll distribute. And I get absolute value of 2x minus 4 equals 0. 0 is an interesting number. And if you were to set up a disjunction, you would notice something. You would notice, well, 2x minus 4 equals 0, or 2x minus 4 equals, who's the opposite of 0? Oh yeah, he doesn't have any opposites because 0 is a beautiful number. Do you guys notice something? Both of your disjunctions, both of the statements, they're exactly the same. So your answer is going to be exactly the same. You're going to get x equals 2 on the left. And it's kind of funny because it's just like, oh, or x equals 2 on the right. So it's like you get two choices. You get x equals 2 or x equals 2. Aren't they the same thing? You only get one choice. Yeah, you only get one solution. Okay? 0 is a beautiful number. So if you ever just go through your homework or your test or something like that and you see a 0 on the right-hand side of your absolute value expression, guess what? You got one solution. You can always double check like I did down here, but again, your only solution is x equals 2. There's your homework. Ask me any questions. I'm always here. And good luck.